Hi everyone. Today we're going to study Stoke's Theorem. Let capital S be an oriented smooth surface that is bounded by a simple, closed, smooth boundary curve capital C with positive orientation, and let capital F be a vector field. Stoke's theorem states that the surface integral of the curl of a function over a surface bounded by a closed surface is equal to the line integral of the particular vector function around that surface. In symbol, we have this formula. The line integral over C, capital F dot dr is equal to double integral over capital S curl F dot n ds. This is our working formula. Example 1. Using Stoke's theorem, evaluate the line integral capital F dot dr, where capital C is any closed surface enclosing a square region of the x equals 0 plane, bounded by the lines y equals 0, y equals 2, z equals 0, z equals 2, where vector f is equal to 2zyj minus 4yzk. Our step 1 here is to evaluate curl f. Given is the vector f equals 2zyj minus 4yzk. For the curl f, this is equal to del cross product capital F. And this is equal to the 3 by 3 matrix. The first row are the components I, j, k. The second row for the partial derivatives with respect to x, with respect to y, with respect to z, respectively. The third row is for the corresponding functions for the components I, j, k. So we have here 0, 2zy, negative 4yz. With respect to determinants, it becomes like this. For component I, we have this partial derivative of negative 4yz with respect to y minus partial derivative of 2zy with respect to z minus for the component j multiplied partial derivative of negative 4yz with respect to x minus partial derivative of 0 with respect to z plus the component k multiplied partial derivative of 2zy with respect to x minus partial derivative of 0 with respect to y. Simplifying this now, we have the quantity negative 4z minus 2y multiplied by I minus quantity 0 minus 0 multiplied by j plus the quantity 0 minus 0 multiplied by k. So we can simplify this further into the quantity negative 4z minus 2y multiplied by I. Now step 2, let us use the Stoke's theorem. We have this formula. Substituting the corresponding values, we start with the curl f, that is the value we derived from step 1. So we have now in here. The ds, we write here dy dz. Now for the limits of integration, the first integral here we write from 0 to 2. This is corresponding to dz. The second integral, we write the limits from 0 to 2. And this is with respect to dy. We just copy this dot n. Now, we let n equals I. That is to conform with this component I in here. So the n becomes I. Now, we evaluate this value of curl f dot I. So we have now this quantity negative 4z minus 2y dot 1. And we can simplify this further into negative 4z minus 2y. Now, let's begin our integration in the inner integral. So the integral of negative 4z with respect to y is negative 4zy minus integral of 2y with respect to y is 2 times y squared over 2. And we can simplify this further into negative 4zy minus y squared. Now let us evaluate this with respect to the limits from 0 to 2. So the first group will be the evaluation of this function with respect to 2 minus the second group. That is, we evaluate this function with respect to 0. Look at the second group. Because of the 0, we can cancel the full second group. Now let us simplify the first group. So the first group becomes negative 8z minus 4. This is now the new function. Let us now get the integral of this function with respect to z. So the integral of negative 8z with respect to z will be negative 8 times z squared over 2 minus integral of 4 with respect to z. This is a constant, so we write 4z. We simplify this part into negative 4z squared, then we just copy negative 4z. Let us evaluate this with respect to the limits of integration from 0 to 2. We evaluate this function with respect to the number 2. This is now the first group. Minus, we evaluate this function with respect to 0, and we have the second group. Looking at our second group, because of this 0, we can cancel this out. Then we can simplify the first group. It becomes negative 16 minus 8, so the final answer is negative 24. Example 2, using Stoke's theorem, evaluate line integral over C, capital F dot dr, where capital C is any closed surface enclosing a rectangular region of the z equals 0 plane, bounded by the lines x equals plus or minus 2, y equals 0, y equals 3, where vector f equals y squared I plus x squared j. For our step 1, let us evaluate the curl f. The vector f is given as y squared I plus x squared j. So the curl f is given by this formula, del cross product v. So this is equal to our 3 by 3 matrix. The first row for I, j, k. Second row for the partial derivatives respectively. For the third row, we write the corresponding functions for the I, j, k. So we write here y squared, x squared, and 0. Now, simplifying this using determinants, we have this expression. For the component I, we have this partial derivative of 0 with respect to y, minus partial derivative of x squared with respect to z. minus the component j multiplied this partial derivative of 0 with respect to x minus partial derivative of y squared with respect to z plus for the component k, this is multiplied by the partial derivative of x squared with respect to x minus partial derivative of y squared with respect to y. Simplifying this, we have this the quantity 0 minus 0 multiplied by I minus the quantity 0 minus 0 multiplied by j plus the quantity 2x minus 2y is multiplied by k. Because of the zeros, this expression is now simplified into the quantity 2x minus 2y multiplied by component k. Step 2, let us now use the Stoke's theorem. And the formula is written here. Let us now substitute the corresponding value for the curl f. Let us modify the ds and let us specify the limits of integration. So we have like this. The ds becomes dx dy. The curl f is here, dot n. For the limits of integration, the first integral has limits from 0 to 3. And this is with respect to the y. The values are here. The second integral has limits from negative 2 to positive 2. And this is with respect to the values of x in here. Of course, this is with respect to the dx. Now, for this n, we let n equals k. We will write this as k so that it will be uniform with our component k. So it becomes like this. So the curl f dot k. So the value will be the quantity 2x minus 2y multiplied by 1. We can simplify this into simply 2x minus 2y. Now let us start evaluating the inner integral. Integral of 2x with respect to x will be 2 times x squared over 2 minus integral of 2y with respect to x, that will be 2yx. We can simplify this portion into x squared minus 2yx. Then we evaluate this with respect to the limits from negative 2 to positive 2. So the first group will be we evaluate this function with respect to positive 2. It becomes like this, minus the second group. That is, the function is evaluated with respect to negative 2. Now let us simplify both groups. So we have here 4 minus 4y minus the group 4 plus 4y. We can combine the two groups. And the simplified form will be negative 8y. So we'll get the definite integral from 0 to 3 of this negative 8y dy. The integral of this negative 8y will be negative 8 times y squared over 2. And we simplify this into negative 4y squared. Let us evaluate this further with respect to the limits from 0 to 3. The first group is to evaluate this function with respect to 3 minus the second group. That is, we evaluate this function with respect to 0. For the second group, because of the 0, we can cancel the whole second group. Now we simplify the first group into negative 36. This is the final answer. I hope you learned something from this video. See you again next time.